We want to determine the inverse of f of x equals x divided by 8x minus 7 and its domain and range. So first, it's important to remember that f of x is the same as y. So this really is the same as y equals x divided by 8x minus 7. And we're going to interchange our x and y. So this will become x is equal to y divided by 8y minus 7. So now we want to solve for y. So we'll need to undo this division. So we will multiply both sides by the quantity in the denominator. So we can divide that out. And over here, we'll also multiply by 8y minus 7. So right now we have 8y minus 7, that quantity multiplied by x, is equal to y. Now, because we want to get y completely isolated, we're not done here because unfortunately, we do have the y by itself on the right-hand side. We have this y stuck in the parenthesis on the left-hand side. And so the only way really to deal with that is going to be to distribute. So we'll go ahead and distribute the x into that binomial. And by distributing, we can drop the parentheses. So 8y x minus 7x is equal to y. Now that distributing was really a key step because at this point, we have a total of 3 terms in this entire equation. And if we look closely, there are 2 terms that contain a y. So we want to get those terms on the same side of the equation. So in other words, we're going to subtract the 8yx term from both sides. So we'll subtract 8yx. That'll leave us with a negative 7x is equal to y minus 8. And I realized I just interchanged these. I wrote it as 8xy. But remember, if I write 8xy, that's the same as 8yx because I can interchange my multiplication. The fancy word for that, it's called the commutative property. I didn't mean to confuse you there. So that would be the same as 8xy if I subtract it over. I tend to always write it alphabetically in alphabetical order, but it does not matter. Now on the right-hand side, we have 2 terms, and there is a greatest common factor in those 2 terms. Both contain a y, so this is where we want to factor out the y. And by factoring out the y, we'll be left with y times the quantity 1 minus 8x. And because we have multiplication, this is what will allow us to now finally divide by 1 minus 8x, thereby isolating y completely. So we'll have y is equal to negative 7x divided by 1 minus 8x. And then I always recommend at the very end that you go back and use the correct notation. And since the original function was labeled f of x, and we just found the inverse, then we would label it as the inverse of f, which will be negative 7x divided by 1 minus 8x. So there's our inverse. Now to find the domain and range of the inverse, we'll take a look at this inverse, and we see that we have a fraction. Now the numerator of a fraction can be any number. So there's no restrictions in the numerator, but we know that the denominator of a fraction cannot equal 0 because we can't divide by 0. So the denominator, 1 minus 8x, cannot equal 0, and we'll solve to find what value of x will cause the denominator to equal 0. So you need to subtract 1 and then divide by negative 8. So x cannot equal negative 1 divided by negative 8, which would be 1/8. So that's the one value of x that we are not allowed to have because if I substituted 1/8 in for x, it would result in 0 in the denominator. So our domain will be all values of x from negative infinity to 1/8, and then we'll skip over 1/8, and then all the values larger than 1/8 would be fine as well. So here's the interval notation for the domain. Now the range is a little bit more difficult to see from the inverse, especially because we don't have a graph. So it's much easier to remember that the domain and the range are going to be interchanged when we find an inverse function. So therefore, the range of our inverse will really be the domain of our original function. So we'll go back to this original function, and we see that we have a fraction again, and we have to recognize that the denominator of this fraction cannot equal 0 either. So let's scoot over a little bit, and we're doing the domain. I'm going to write it as the domain of f. So I'm going to put D for domain, the domain of the function f of x, the original. The denominator 8x minus 7 cannot equal 0. So if you add 7, 8x cannot equal 7. Divide by 8, and that gives us that x cannot equal 7/8. So the domain of the original function will be all real numbers except for 7/8. So negative infinity to 7/8 union 7/8 to infinity. And then that will give us the range of the inverse. So down here, the range, which will be all the possible y values, will be from negative infinity to 7/8 union 7/8 to infinity. So it's important to remember, if you are stuck and you can't figure out the range of a function or its inverse, that will always be then the domain of the original.